Hello everyone. Today we will be solving the problem number of submatrices that sum to target. So the problem statement is as follows. Given a matrix and a target, we need to return the number of submatrices that sum to target. So a submatrix is defined by the upper left corner and the lower right corner. And yeah, so this is the first sample 0, 1, 0, 1, 1, 1 and 0, 1, 0. We need to find all those submatrices that have a sum of 0. As we can clearly see, there are only 4 cells in the whole matrix that have the value 0, and these are the only submatrices that have the sum 0, so we need to return 4. So after reading this problem, what's the most naive way of solving naive approach that comes to our mind? We can clearly iterate on all possible upper left corner and all possible lower right corner and count the sum, calculate the sum of that sum matrix and check if it's equal to the target or not. So the iterating part on the upper left cell and the lower right cell would itself take big O of n to the power 4 time complexity. And if we were to calculate the sum in a naive way, that is big O of n square, our whole solution would end up taking big O of n to the power 6 time complexity. That's not very efficient, but we can definitely improve on the computation of sum of a submatrix part. Instead of taking big O of n square time to each time we calculate the sum, instead what we can do is we can pre-compute the prefix sum of f for every cell. So let's say we have this as a matrix. Prefix sum of 1 comma 2 would denote what would be the sum of the submatrix that starts from the 0 comma 0th cell up till 1 comma 2, which is this portion. Prefix sum of 0 comma 3 would denote what is the sum of the submatrix that starts from 0 comma 0 up till 0 comma 3. So after we have pre-computed this part, calculating the sum of a submatrix becomes quite easy. How would we do that? Let's say we were to find the sum of the submatrix ABCD. What we can do is we can take the sum of the whole submatrix, subtract the part that we don't need. What is the part that we need first? We need this part. So what we don't need is this part and this part. We can subtract this, and since we have subtracted this portion twice, so we need to add it once again. So if we look at the code, here we pre-compute the prefix sum. It's quite easy. If we, for each cell, what we do is, let's say for 1 comma 2 we need to calculate. What we would do is add the prefix sum of this portion, add the prefix sum of this portion, and since this portion has been added twice, we need to subtract it. That's what we are doing here. If the upper row exits, then add its value. If the left column exits, then add its value. And if the diagonal 2 exits, then subtract its value. And finally, we iterate on every possible upper left and the lowermost bottom right cell and check the sum. And this is the sum function, which returns the sum of the submatrix in big O of 1 time complexity. And if that's equal to target, we increment our answer and return it. So the overall time complexity for the whole solution would be big O of n to the power 4, since we iterate on every possible upper left cell and every possible lower right cell. However, if we clearly look at the constraints, that would amount to big O of n to the power 8 complexity, 10 to the power 8 complexity. So that's not very efficient. We need to optimize on that part. If we look at the problem again, let's forget that we need to find the number of submatrices that sum to target. What if the original problem statement was not a 2D array, but a 1D array? For example, let's have a table of this. Yeah. So if we want to find the number of subarrays having a sum of target, what we would do is we can maintain a running prefix sum, and if our current at any point our current sum is s, we need to look up how many indices before, let's say we are at current index is I, we need to find how many indices less than I had a sum of current sum minus target. This can be done by maintaining a hash map and this move it here. Let's move it here. Yeah. And this and this. Okay. This can be done by maintaining a hash map, and we could easily do the lookup. So if we were to write a pseudocode for this, like for int I equal to 0, I less than n, I plus plus, let's say current sum plus equal to the array value of that index, and we need to increment our answer by frequency of sum minus target, and finally return our answer. So this we would have done if the original problem statement involved 1D array instead of 2D array. So we need to find a way to model the original problem statement to this 1D array problem. How can we do that? Say we fix two columns. We need to find submatrix. So let's say we fix the columns of the submatrix. Now what the problem reduces to is we have a set of rows and we need to check the prefix sum of the entire row and do the same thing that we did for the 1D array. Consider this whole cell to be a one specific index of a 1D array. Similarly, this as well. So finally, our problem boils down to find the number of subarrays which sum to target. So that would be quite easy. We can do the exactly same algorithm that we followed here. So let's write the code for this. Let's maintain a prefix sum of each row sum. First, let's get the dimensions, matrix dot size, and let the column be denoted as m, matrix 0 dot size. And let's create a 2D vector which would store the row sum. And now we iterate on every possible rows and every possible columns, and row sum of I comma j will be matrix of I comma j, plus if the left cell exists, then we add row sum of I comma j minus 1, else 0. So here we have pre-computed the row sum for each row. Now let's initialize our global answer and let's iterate on the columns that we had discussed earlier. And the column 2 will start from column 1 because let's say we had only one column, let's say this part, and this can be m and called to plus plus. Let's be called to yeah. Now, so we have a current running sum, and then we have a hash table to store the frequency. And since the sum of an empty subarray would be 1, so we can store the frequency of 0 as 1. Now we iterate on all the rows. Row will be 0 till n, row plus plus. We need to find row subarray sum, that will be row sum of row comma column 2 minus column 1 minus 1 is greater than equal to 0. Then we'll have row sum of, let's make the editor a big, yeah, row and column 1 minus 1, else 0. And we add this to our global sum variable. And finally, we check if there exists a variable sum minus target in the hash table, then we increment our answer by frequency of sum minus target. Finally, we return our answer. So let's try running this. Okay. Let's try to find the error here. Okay, we are not incrementing our hash table. So let's try running it again. Yep, it did run. Let's try submitting. Yeah, as you can see, it passed. So the total time complexity for this solution will be big O of we are iterating on every 2 columns, and then we are iterating on every possible row. So it will be nm square. And the space complexity, because we are using an extra space of row n into m, so it will be a big O of n square m. So that's all for this video. If you liked it, please hit the like button, and I'll see you next time.